get the range of either secant or a cosecant function. In this case, we have a secant function. We're going to start with the generic range, which is all of the numbers except for numbers in between 1 and -1. So since cosecant is 1 over sine, we're going to be looking at every number with the exception of things that are between -1 and 1. So everything that is in the range of sine is not in the range of cosecant, with the only exceptions being 1 and -1. We're going to take that base range and multiply it by the amplitude, or the value of a in this case. We're going to multiply that whole thing by 7. And that's going to give us a range of -infinity to -7 union +7 out to infinity. So in general, the range of a secant or cosecant function will be -infinity to negative the amplitude union positive amplitude to positive infinity. And then if I had a vertical shift, I could add that in here. The period actually hasn't changed from the way that we calculated the period for sine and cosine. I just want 2 pi divided by b. So 2 pi over 4, which simplifies to pi over 2. So the new thing that we get are the asymptotes that happen in the graphs of all of the other 4 trig functions. And these asymptotes are going to occur whenever the denominator is 0. In this case, we're looking at a cosecant function, which means that I'm going to have an asymptote whenever sine would be 0, which has the base equation of theta equals k pi, where k is any integer. Because if we look at the unit circle, sine is 0 at all of the horizontal axes. So 0, pi, and 2 pi, 3 pi, etc. To find the specific equation for vertical asymptotes for a given function, I'm going to look at everything that's on the inside. So in our case, 4x minus pi over 5. Since 4x minus pi over 5 would give me whatever angle it is that I'm actually plugging into the cosecant function. And I'm going to set that equal to k pi. And then solve for x. So 4x is equal to pi over 5 plus k pi, meaning that x is equal to 4 pi over 5 plus, nope, we're going to have to make an edit here. This is pi over 20 plus k pi over 4. And if I wanted to get a common denominator here, this could be pi plus 5k pi over 20. To add just one extra step to this problem, say that you were looking for some specific asymptotes for this function instead of just the generic equation for them, I should plug in specific values for k. As an example, let's take k equals 0, k equals 1, and k equals 2. Just come up with 3 equations, 3 specific asymptotes for this problem. I would be looking at x equals pi plus 5 times 0 pi over 20, pi plus 5 times 1, over 20, and x equals pi plus 5 times 2 pi over 20, giving us values of pi over 20, 6 pi over 20, and 11 pi over 20. All right, and the range for this next function, I'm going to be interested in that 8. So this range should be negative infinity to negative 8, union 8 to infinity. That period be 2 pi over 2, which is just pi, and those asymptotes I'll take 2x minus pi over 7 and set that equal to k pi and solve for x. The 2x is equal to pi over 7 plus k pi, meaning x is pi over 14 plus k pi over 2, or 2 pi plus 17k pi over 34. For secant, the amplitude works just the same. Negative infinity to negative 7. Union 7 to infinity. Period also works just the same. 2 pi over 8 in this case is pi over 4. But the equation for the vertical asymptotes will be different this time. Since secant is 1 over cosine, this time I need to get all of the angles where cosine is equal to 0, which is going to happen at all of the vertical axes. Pi over 2, 3 pi over 2, 5 pi over 2 if we keep going around the unit circle, or negative pi over 2 if we went backwards. So the general equation before transformations is going to be theta equals k pi plus pi over 2. So this time I want to take 8x minus pi over 4 equals k pi plus pi over 2 and solve that thing for x. If I add pi over 4 to the other side, I should get 3 pi over 4 plus k pi, as long as I combine the pi over 4 with the pi over 2, and then divide both sides by 8. 3 pi over 32 plus k pi over 8, or 3 pi plus 4k pi all over 32. So we have another range where we'll want negative infinity to negative 9, union 9 to infinity. That period should be 2 pi over b, which in this case is 2 pi over 4. That simplifies to pi over 2. And for those vertical asymptotes, 4x minus pi over 6 is equal to k pi plus pi over 2. Solve that for x. All right, continue solving that for x. And we get pi over 6 plus k pi over 4. Or if we wanted to simplify that, 2 pi plus 3k pi over 12. For tangent and cotangent, which is sine over cosine, the range on these actually does not change at all. No matter what values of a, b, and c we use, we always have a range of all real numbers, just like the domain of sine or cosine. The period is actually also a little bit different. When it comes to the period of tangent and cotangent, these functions have a base period of only pi instead of 2 pi, because these things repeat their cycle every half circle instead of every full circle. So it should just be pi over b, as opposed to 2 pi over b. So when it comes to tangent and cotangent, the base formula for the period is different. So we'll be using pi over b instead, which should be pi over 3. To get the asymptotes, though, that works just as it would with secant in this case. Since tangent and secant both have a denominator of cosine, they both have the same base function or base equation for their vertical asymptotes. So I'll take 3x minus pi, which is the interior, and set that equal to k pi plus pi over 2. And then solve for x. So 3x is equal to 3 pi over 2 plus k pi meaning that x is pi over 2 plus k pi over 3, which could be simplified to 3 pi plus 2k pi over 6. And for cotangent, the range is all real numbers, just as it is for tangent. The period of cotangent is also pi over b. So just regular pi, not 2 pi, because again, tangent and cotangent both have a base period of 1 pi. And for the equation of the asymptotes, 4x minus pi over 9, this is just equal to k pi. And solve for x. So 4x is equal to pi over 9 plus k pi, meaning x is pi over 36 plus k pi over 4, or pi plus 9k pi over 36.